Hi there, my name's Steve Sinclair from Team Merkle, and as part of the Codeless event through the OGTC and the Ingenious conference, we've been developing an application as part of the hackathon over the past few days. Our application is around smart root cause analysis for faster fault discovery through SCADA data from wind turbines. So the business challenge, as we see it, is that wind turbines can have serious faults which impact on their power production capabilities, and they can incur significant maintenance costs, particularly across the scale of a field. And anything we can do to reduce those faults, to increase uptime of power production, uptime of turbines, or reducing those maintenance costs will help with the viability of wind farm field. Now, we have SCADA and alarm data available to us now. So really the business challenge is around what can we develop and build today that can help impact on these issues. So our solution for the hackathon was around connecting the field engineer to the sensor and alarm data in a way that they could perform a root cause analysis on site and support that analysis with historic information about that particular fault or that particular turbine, so they get real in-depth look. Now, the outcome of that site inspection, we're managing through a chatbot, and we're capturing all the relevant data so that could be saved and used for future analysis at a later date. Now, the outcome of all of this is really looking for efficient management of turbine faults from end to end. So all the way from engineer to, say, a stock control system, for example. Now, the data capture element means that the system can really scale. So as we add engineers or additional turbines or fields, we can learn from their root cause analysis and what they did to fix particular faults. So we have that real sense of a human in the loop. So you connect the human to the data, and then you can start bringing in AI, machine learning elements. So the more that the system's used, the more efficient it becomes. So I'm going to hand over to my colleague, Charlotte, and she will demo the app that we've actually built.
Thanks, Steve. If you just stop sharing your screen and I'll move.
Sure. Okay.
Okay, so I'm going to demo the app to you. So as you can see, we've got the app here. Make that full screen so you can see. So I would be an engineer and I'm going on site and I'm looking at the app that we've got. The first thing I can do is I can look at the alarm analysis. So this is going and pulling through the alarm data that we've got. We've done a bit of aggregation of data. We've clustered the alarms into 10-minute sections, and we can see that the alarms that were going off for the latest fault that we've got are sitting over here. Those are then broken down into the different types of alarms, as you can see up here. What we then do is we use the alarms that are prevalent, and we filter through the previous inspection reports that you can see there with the previous issues that were causing these sets of alarms. So it's a bit of pattern matching. What we've also got on this screen then is we've got the ability to go through to some alarm AI. So this would be for, at the moment it pulls back the reports, but what we would see here is we would see as the app is learning and more with the machine learning, and as it progresses, then this would give smart recommendations so that the engineer knows exactly what things that they can look at and go and do. So I'm on site, I've had a look at my problems, I've had a look at my alarms, I've looked at the historical stuff. Now I want to look at the live sensor data. And when I do that, I get real-time SCADA information, so the sensor data that comes back in real time, and it gives me the plots of what's going on. So I can see I've got blade data, wind speed. This allows me to check, are my theories and my hypotheses based on the historical reports correct? Is there anything in the current sensor data that maybe might make me think that something else is going on? I can carry on and go through again to the inspection reports, and I can look at those reports again. If I think that maybe there's another problem, I can create a new report here. This will allow me to fill one in with the root cause of the problem and the alarm types. It allows me to save it. It'll also, with the automated flows behind, will also store all that information so that, as Steve was saying, that the app keeps on learning. If I've finished all the work that I've done and I've actually fixed the problem, I can toggle this button at the top and say that the problem has been resolved. That shuts off all the alarms and does some wrap up. The other thing that we've got on our app as well, we've got this little symbol is on every screen, so you can access this from any screen, but we've also got our virtual agent, which will come up with the screen. And I'm going to hand over to Jake, who's going to explain to you how that works.
There we go. All right, thank you, Charlotte. So the function of the chatbot is to wrap up the fault analysis that we've seen so far. And there's essentially two functions to it. So the first function, which is good news, is if the fault has been resolved. So if that previous screen was toggled and the reports that have been given have allowed the engineer to solve the fault, we can navigate through that branch of the chatbot. And the purpose of that is to gather just a little more information. So there's an open text input that allows the engineer to tell us what's been learned from the fault, any extra information that wasn't in the reports that would be useful for future analysis, and that feeds into the AI solutions that can inform any future similar alarm. If the fault hasn't been resolved, so there's a few reasons that could be. So we'll go down that branch now. If you haven't been able to fix the fault based on the reports that were given, we hypothesized that one of the most likely reasons for that might be that a part was missing. So if the engineer arrived on site, they've identified the problem, but for example, there's an issue with the blade and they need a replacement. This is where the functionality of the chatbot comes in, because the chatbot would be connected to live updating entities. So that would be a stock management table. The chatbot can access current levels of stock and tell the engineer what's available. And if, for example, they require a blade, thankfully there's one in stock, it will tell them how long that will take to deliver. So that can live update based on their location and the location of available stock. It's an iterative process, so anything that's kind of not listed on the table, they can input that and that will update in the future. And as we can kind of see from going through the process in real time, it logs that order with an agent, and also we log the data against the stock quantities that we've got. So we're picking up quite a lot of data there, both in terms of the stock order that was placed, and we can use that for stock management. We can use it for informing future reports. So if someone comes through with a similar problem in the future, we can kind of implement a smart solution that tells us this is likely to be what's required, and that can be used for future stock updates.
Great, thanks, guys.
Is that you done?
No, just one second.
No, that's fine.
That's great, thanks, guys. So just in summary, so what the guys were saying this, an engineer arrives on site and starts interacting with our application. That application is pulling data in from Intelligent Plant in this case, which is pulling data through from a live turbine. The engineer then interacting with the application is actually interacting in the background with all these different Microsoft Power Tools. So really the full suite's being used here. So Power BI, Power Apps, Power Flows, and the Digital Assistant. And they're all working together in the background to help the engineer identify the fault and make decisions off the back of that. What's really nice about this as well is we can also have that information flowing to the wider team, be that a management team, stock control, personnel management, things like that. So really getting the view that a single central location can help actually across quite a wide team through the use of that data. The other thing we have is the concept of collecting data as we go. So we really like the idea of the application is able to learn. So we're able to save that data down to, say, something like an Azure data lake. And that would allow us in the future to build out AI, machine learning applications, sort of mine the text data in particular, so those faults and resolutions, with the idea that recommendations could then be served to the engineer at a later date to help speed up that whole diagnostic cycle. So that's our app. Finally, just want to say a quick note of thanks, particularly to the mentors that we had available to us through the hackathon. Their technical support was invaluable and really enabled us to quickly put together our application. And I don't think we would have been able to do nearly as much as we were able to without their support. So thanks, guys, again.